Hello everyone, welcome to the class. This is the third video on study of gas laws. Okay, so in second video, I had explained you regarding temperature, pressure, and the last part of the second video was I gave you one question and then I left, isn't it? So the question was define volume and give its various units. Okay, so because of storage problem in my this phone, I could not make a single video on this temperature, pressure, and volume. Okay, so I'll continue in this class. So volume, I have already given the question. Okay, define volume and give its various units. So ensure you write it. Volume is defined as the space occupied by an object. Volume is defined as the space occupied by an object. So there is no specific formula for finding the volume of an object. Okay, the volume of an object depends upon the shape of that object. Okay, so if the object is in cuboidal shape, cubical shape, if it is in cubical shape like this, if it has definite shape like cube shape, then you can find its volume by multiplying its sides, three sides, length, breadth, and height. Okay, side into side, side into side into side. If you have spherical object, then its volume will be 4 by 3 into side cube. If you have, say, a cuboidal object, okay, then its volume will be length into breadth into height. And for stones, you cannot find the volume by using a particular formula. Okay, so you have to use a different concept for finding the volume of objects like stones and all. Okay, because they don't have a particular shape. Some standard objects, you can calculate their volume by using some specific formulas. Okay, so volume definition I have already given. Now units of volume, units, units of volume, units of volume. SI unit of volume is meter cube. Meter cube. Its symbol is meter cube. SI unit of volume is meter cube. And we write meter cube like this, m cube. Okay, and some other units are also there. Some other units of volume are centimeter cube, millimeter cube, decimeter cube, liter. It stands for liter. Okay, liter, milliliter, ml stands for milliliter, and some other units are also there. So these are the most commonly used units of volume. Okay, first of all, you remember meter cube, SI unit of volume is meter cube. The centimeter cube is CGS unit. Okay, and these are some additional units of volume. Next important thing is make a note. Okay, note 1 meter cube is equals to 1 meter cube is equals to 1000 liters. 1 meter cube is equals to 1000 liters, and this is also equals to 1000 decimeter cube. dm means decimeter cube. Okay, dm stands for decimeter. Number A is this, number B is 1 liter. 1 liter is equals to 1000 milliliter, and this is also equals to 1000 centimeter cube. This is also equals to 1000 centimeter cube. These two relations you note and memorize properly. Okay, while doing numericals, we have to convert meter cube to liter. Sometimes we have to convert decimeter cube to liters, and sometimes we have to convert liter to centimeter cube, and so on. Okay, so we have completed the definition of temperature, pressure, and volume. Now let's move on to gas laws, okay, the exact content of the chapter. So I have already explained you in this chapter you have to do two different laws. Number one is Boyles law, number two is Charles law, and number three is also the additional combined form of Boyles law and Charles law. So write down question. This is very important question, okay, very important. Define Boyles law and give its mathematical form. Define Boyles law and give its mathematical form. So answer, write down Boyles, B-O-Y-L-E apostrophe S, Boyles law. Statement I will give you later, okay, just I'll first write mathematical relation. Mathematically, Boyle's law says that volume of a given temperature and mass, okay, when temperature and mass is kept constant, Boyle's law states that volume of a given mass of a gas is inversely proportional to its pressure provided the temperature remains constant. This and mass I'll not write, okay. So Boyle's law states that volume of a given mass of a gas, given mass means mass is fixed, okay, given mass of a gas is inversely proportional to its pressure, ITS, its pressure, provided the temperature of the gas is kept constant. Mathematically, V is, this symbol is proportion, symbol of proportion, okay, proportional to 1 by P, inversely proportional. We did V inversely proportional to P. If you put a constant, then V will be equals to some constant into P upon P, where K is equals to some constant. From here, V into P will be equals to K. K is constant. Therefore, we can write V1 into P1 is equals to V2 into P2 when temperature and mass of the gas is kept constant. So this is the mathematical form of Boyle's law. Okay, Boyle's law says that volume of a given mass of gas, don't forget the word given mass, given mass of a gas. Given mass means mass is fixed. It might be 1 kg, 2 kg, 3 kg, 4 kg, okay. So mass is fixed, is inversely proportional to the pressure provided the temperature of the gas is kept constant. Mathematically, V is inversely proportional to pressure, V proportional to 1 by P. From here, if you remove this proportional sign, then you have to keep, you have to put some constant, okay, let that constant be K. So V is equals to K by P, where K is some constant. From here, if you cross multiply, V into P will be equals to K. And from here, K is constant, so Vp is equals to constant, V into P is equals to constant. So you can write V1 into P1 is equals to V2 into P2. This is the mathematical form of Boyle's law. So just as in simple language, Boyle's law says that, suppose if you have some gas in this, see, simple language I am explaining, okay. This is your container, this is a container, gas jar. So if you have, see, 5 meter cube of gas in this container, 5 meter cube of gas in this container, okay. And if you apply pressure from up, if you apply pressure from here, keeping its temperature is say 10 degrees Celsius. Right now this gas is at 10 degrees Celsius. If you keep the temperature constant and if you apply pressure from top, okay, what I was saying, okay, so I'm saying, so you have 5 meter cube of gas in this container, okay. The temperature of this gas is 10 degrees Celsius. By keeping the temperature constant 10 degrees Celsius, if you apply pressure on this gas, then what happens is its volume decreases. Volume will decrease. Its volume decreases, okay. So this might reach here. The gas might get compressed and its volume might be reduced to 2 meter cube. So on increasing pressure, volume of gas decreases. If you compress gas, if you apply pressure on gas, its volume decreases. That is the inverse relation, okay. With the increase of pressure, volume decreases. With the increase of pressure, volume decreases. They have reciprocal relation, okay. If one increases, another decreases. So Boyles law says that volume of a given mass of gas is inversely proportional to the pressure, provided the temperature of the gas is kept constant. Mathematically, you should know this statement, okay. Next, let's move on to another law, that is Charles law. CHARLE' Charles law. Charles law, okay. So write down question. State Charles law and give its mathematical form. First I'll write mathematical relation, okay. Mathematically, statement I'll give you later, okay. Mathematically, so Charles law states that volume of a given mass of a gas is directly proportional to its absolute temperature, okay. Otherwise you can simply say its temperature, provided the pressure of the gas is kept constant. So when pressure is kept constant, volume of a given mass of a gas is directly proportional to its temperature. That means it is with the increase of temperature, volume also increases. That is Charles law, okay. So with the increase of temperature, volume also increases. So statement is, Charles law says that volume of a given mass of a gas is directly proportional to its temperature, provided the pressure of the gas is kept constant. Mathematically, V proportional to T, and if you remove this proportional sign, V will be equals to some constant into T, where K is equals to where K is some constant. V upon T, if you cross multiply, T will go down in the denominator of V, okay, is equals to K. So you can write V1 upon T1 is equals to V2 upon T2. This is the mathematical form of Charles law. This is the mathematical form of Charles law. V1 upon T1 is equals to V2 upon T2. So statement of Charles law, you can refer your book also, okay. Charles law says that volume of a given mass of a gas is directly proportional to its temperature, provided the pressure of the gas is kept constant. Mathematically, V directly proportional to T. Okay, V is equals to, from here you can derive this relation. The exact form of Charles' law is this. I have quoted within the box. Okay, that means in simple language, if you have some gas here, it is right now it is at 10 degrees Celsius. Its volume is say 20 liters. If you heat this gas, if you convert its temperature to 30 degrees Celsius, then volume will also increase and it might reach to nearly 60 liters and all. Nearly, just this approximation only. Okay, I mean to say is, with the increase of temperature, volume also increases, provided pressure of this gas should be kept, pressure within this container or pressure of this gas should be kept constant. Okay, next you write it. Give the mathematical statement for combined form of gas laws. Give the mathematical statement for the combined form of gas laws. Okay, and answer write it. The mathematical statement for combined form of gas laws is P1 into V1 upon T1 is equals to P2 into V2 upon T2. This is the mathematical form of combined form of gas law. When you combine Boyles law and Charles law, you will get this P1 into V1 upon T1 is equals to P2 into V2 upon T2. Okay, using this relation, we have to do some numericals. It is there in your syllabus. Derivation of this is not there. Okay, you need not to derive this relation. Just remember this. P1 V1 upon T1 is equals to P2 V2 upon T2. Okay, this much for today's class. Remaining portion I will continue in the next class. In next class we will be studying, we will be doing the importance of Boyles law, okay, the importance of Charles law and their applications. And I'll teach you some numericals also, okay, regarding Boyles law and Charles law and the combined form of Boyles law and Charles law. Okay, thank you.